Good afternoon, everyone. I'm sorry that I can't be there with you again today, but I do promise that I will for sure be back in class tomorrow. Today we're going to be looking at the remainder theorem. So the past 2 days we've been looking at different types of division. First we did long division, and then yesterday we looked at synthetic division. Today we're going to be looking at the remainder theorem, and it's going to help us out with a little bit of our division. But first, what we're going to do is we're going to recall 3 of the different division problems that we've looked at in some of our previous notes when we did those divisions. We had 3 different polynomials, and they were divided by these different factors. And we're just going to recall what their remainders were. So this first one, it had a remainder of a negative 18. The second one had a remainder of 12. And the third one had a remainder of 3. Now, right now, these remainders may not seem important, but I want you to remember these 3 numbers when we look at our next example. So in this example here, we're looking at the exact same 3 polynomials, and we're asked to evaluate at these different values here. So what we're going to do is we're going to plug in those values into the equations. So we're going to have a negative 5 squared plus the 3 times negative 5 minus 28. So negative 5 squared gives us 25. 3 times negative 5 gives us a negative 15. And minus 28 at the end. When we evaluate that out, we find that we get a negative 18. Take a look at the second one here. Again, we're just plugging in the value for x into the equation. So we have a negative 1 cubed minus 7 times a negative 1 plus 6. So negative 1 cubed leaves us with still a negative 1. Negative 7 times a negative 1 leaves us with a positive 7 and plus 6 at the end. So when we evaluate that out, we get a value of 12. And our last example here, plugging in 1/2 this time. So we have 4 times, and I'm going to write it as a decimal, 0.5 cubed minus 4 times 0.5 squared minus 3 times 0.5 plus 5. Now to evaluate that out, we're going to do 0.5 cubed and multiply it by 4. So 0.5 cubed is 0.125, and we're multiplying that by 4, which gives us just a 0.5. Then we have 0.5 squared, which is 0.25. Multiply that by 4, and we're left with 1, and it's a negative 1 because that was a negative 4. And then a negative 3 times 0.5 gives us a negative 1.5, and then plus 5 at the end. When we evaluate that out, we're left with 3. What do you notice about these 3 numbers, negative 18, 12, and 3? I'm hoping that you've noticed that we have gotten the remainders from yesterday. So these three numbers, negative 18, 12, and 3, were exactly the three remainders that we had gotten when we did our division yesterday, negative 18, 12, and 3. But one thing I want to also make note of is, where do these values of x come from? So we plugged in a negative 5. Why did we plug in a negative 5? When we look back at our factor that we divided by, in the first one, we divided by an x plus 5. So this x minus 5 was just the value of that factor. But that, remember from yesterday, we looked at the k value when we were doing synthetic division. So it's the same idea. Because it was x plus 5, we want this to plug in an x minus 5. Look at our second one, we plugged in a negative 1. But again, that makes sense because our factor was x plus 1. So when our factor is x plus 1, the actual x value is negative 1. And our last one, our factor was 2x minus 1, and we plugged in a 1 over 2. And hopefully maybe you remember a little bit when we looked at synthetic division yesterday, when we had to put that in something like this with synthetic division, we had to put that in where there was no value in front of that x. We had to rearrange it, and that would have given the x minus a half, which is then why we plug in a positive a half. And again, these factors, remember, they just give us the roots of our divisors. So they're just the roots, which remember are the same as x-intercepts. So this brings us to the actual definition of what the remainder theorem is. So the remainder theorem tells us when a polynomial function, represented by p at x, is divided by a factor of the k minus x, we know for sure that the remainder is p at k. So we plug in that number of our factor into our function to get our remainder. And similarly, when a polynomial function, p at x, is divided by jx minus k, that's when there's that number in front of that x value, we know that the remainder will be when we plug in k divided by j into our polynomial function. And we just saw that in those past three examples. Now this can be really helpful to us when you're doing long division or synthetic division, and you would want to double check, and this can be a quick check to see if your answer is correct. You take your k value and you plug it into your polynomial function. If you get the same remainder that you got after you did your division, you know that you did your division correctly. So we're going to look at an example. Asks us to determine the remainder of this polynomial when it's divided by x minus 5. Oh, and sorry, that should actually be an x plus 5. So because our factor is an x plus 5, that means we need to plug in when x is equal to a negative 5. So in our polynomial, plugging in a negative 5, so we have a negative 5 cubed plus 6 times negative 5 squared minus a negative 5, and then minus 30 at the end. So when we have negative 5 cubed, that leaves us with a negative 125. Negative 5 squared is 25, and we're going to multiply that by 6, so 25 times by 6 gives us 150. And then minus and negative 5 is actually just plus 5. And we still have our minus 30 at the end. When we add that all up, we actually get a 0. So negative 125 plus 150, then plus 5 minus 30 leaves us with 0. So actually in this case, the remainder, when that polynomial is divided by x plus 5, is 0. We're going to look at one more example. So it gives us this function here, and it tells us that it has a remainder of 6 when it's divided by x minus 2, and it wants us to determine the value of b. So what we know so far from the information that we've been given, we know that p at the value of 2, so our function p at x, when we plug in the value of 2, which is plugging in this k value, and we plug in the value of 2, we know for sure that we get a value of 6. Because from our remainder theorem, we know that when we plug in the k value of our factor, we get the value of our remainder. So when we write this out, in our function here, we're going to plug in where we see an x, we're going to plug in the value of 2. So we're going to have a 2 to the power of 4 plus b, we don't know that value, but we're going to have 2 squared minus 7. And we know that this all needs to be equal to the value of 6. And this is just our function with plugging in the value of 2. So then let's try and simplify this out and rearrange and solve for b. So 2 to the power of 4 gives us 16. 2 squared leaves us with 4, and it's times b, so we have a plus 4b. And then we still have minus 7, and it's all equal to 6. So now we need to start rearranging things, so we're getting our value for b. So we're going to leave 4b on this side. So we're going to have 6. We're going to add 7 to bring it over to this side. So 6 plus 7 will give us 13. Then we're going to move this 16 over. So it's going to be 13 minus 16, which leaves us with a negative 3 on that right-hand side. So we just rearranged all the numbers and brought them all over to the right-hand side. And then our last step to get b by ourselves is we need to divide by 4. So we get that b is equal to a negative 3 over 4. So we know that in our polynomial function here, that b value has to be a negative 3 over 4, since our remainder was equal to 6 when we divided by our polynomial of x minus 2. So we're going to see other ways that this can help us in the next few days as we continue looking at other theorems that are going to help us with our divisions. So today, here's your homework. There should be lots of time left in class because this is a very short lesson. So if there's any struggles that you had in the homework, this would be your chance to work on them. Otherwise, take a look at these homework questions. I expect that you be using your time wisely in class. I'm giving you lots of class time and I'm trying to make the lesson short since I wasn't be able to be there. So please make use of your time wisely. Get all this homework done. I will be back tomorrow, so you can always ask me any questions that you have in that point in time. Hope you guys have a great day, and I'll see you tomorrow.